My guest today is Professor Ben Levinstein, who is an associate professor at the University of Illinois, who specializes in formal epistemology, decision theory, philosophy of science, and increasingly in the ethics and philosophy of artificial intelligence. Much of Ben's work, past work, has developed new accounts of rationality for both belief and action. Welcome, Ben.
Thank you. Glad to be here.
Yeah, so I want to focus on one of your latest papers that you wrote with Simon Goldstein from the University of Hong Kong. It's entitled, Does ChatGPT Have a Mind? It's a question that a lot of people are asking. So you say here in the introduction, recent developments in AI are stunning. Large language models like ChatGPT can generate text that's fluent, accurate, and responsive to human questions. These advances have sparked a fundamental question. Do these AI systems possess minds? So, I'm not a computer scientist, nor a philosopher, Ben. But I have done a lot of, well, I shouldn't say a lot of, peripheral work in the area of artificial intelligence for about 35 years. And these are questions that I've been asking myself for a long time. But we want to get some definition. So mind, do we have a theory of mind for humans yet? Or it's still, yeah.
Well, I mean, I think, and you see this, I imagine, as an engineer as well, but especially in philosophy sometimes, we come in with these fairly vague concepts that that are very useful, but that can mean a lot of different things to a lot of different people. So if you say, what does it take to have a mind, or what's the theory of mind for humans? You'd probably need to say a little bit more before I could give you a clear answer. And I think, that's fine. One thing that's kind of useful about this is thing like, what are the interesting aspects of having a mind, or what are the kind of features that we can operationalize and that we would really care about? And then check which of those ChatGPT has or doesn't have.
Yeah, so also just for the general audience, so ChatGPT, I think most people have heard about it. Large language models. I think people have some sense of that.
Mm-hmm.
Do you want to sort of just give a quick description of what ChatGPT is and what LLMs are?
Sure. Yeah. So, if you don't know, I would really encourage anyone to go and start playing around with ChatGPT. Or some other large language model, and just start having conversations with it. The way that it really works is, you input some text. You could say, ask it a question like, it's a question like, could you write a good college essay on something? Or could, anything you like, and it would come up with a response. It would just write some fluent English prose that seem generally fairly, at least grammatical, and fairly sensible. You might ask it to write some code for you. And, there's a lot going on under the hood, right? You input some text. It has to somehow process that text that you inputted, that you asked it, called the prompt. And then it has to figure out what to say.
Yeah.
And I can say maybe a little, I don't know if you want to go into the details of like how that works at a high level or not. But
yeah, absolutely.
Right. So in effect, the way that's initially trained is that it just sort of, it's people call it this glorified autocomplete,
Yes.
Which, I think is a little misleading, but in a sense, that's what it is. So what you can imagine is, it starts out, it doesn't know anything, and it starts just outputting total gibberish. You say, the current president of the United States is, and it'll say like banana or aardvark or something. Like it won't say anything that makes any sense at all. And you have to train it before it can do anything reasonable. And you can imagine, effectively the first way we train it is we do something like feed it a bunch of Wikipedia essays or articles. A bunch of other stuff too, but it'll take an article from Wikipedia, and it's always just trying to guess what the next word in the article is. So if I say something like Luanda is the capital of, and then it'll assign some probability to Angola, And
Yeah.
imagine in the real world, in the real essay, the text from the wild, Angola is the next word. Then we kind of tweak it just a little bit so that the next time it would be more likely to predict. It would predict Angola with a slightly higher probability. So it sort of, in effect, generates a probability over what the next word will be, given all the previous stuff, right? And we kind of just constantly make these minor tweaks so that it can make better and better predictions. And after a while, it gets like really, really good at doing that.
So, let me ask you this, Ben. So, this is a little bit peripheral, but I just want to get a better understanding of this. So, do humans do so? Suppose somebody asked me what's the capital of Rwanda, and I have, let's say, 4 or 5 choices. Do I really assign probabilities to those choices, or do I come with some sort of a binary guess on that? So in other words, what I'm asking is, do machines do similar things like humans do, or something different?
Well, I think, when you ask that kind of question, I mean, it's definitely not the same for how machines are doing it and humans, right? I mean, that's just not how children learn language, is by just guessing what the next thing that's going to be said is, right? It's just like, this is just always trying to guess what the next thing that it's sort of as if what would happen is the kid is just always trying to guess the next word out of the parent's mouth or something, right? That's not how humans do it. I mean, I think there might be some question over whether there's something like probability distributions, but it's just a very different process from how humans learn language. Nonetheless, this also results here in pretty fluent text after enough training. I should say maybe one other thing just to make it clear. There's sort of a second process, which maybe I'll just say at a very high level, is basically teaching any of these LLMs that you might interact with to say what you want to hear. So, so after it gets really good at predicting what comes next, we need to make it more chatty, maybe less offensive, and more useful in conversations. And then kind of after, so the second phase of training, called fine-tuning, we might do something like reinforcement learning from human feedback, where it gives some answers and then we get people to rate, did you like that or not? And then, a bunch of other voodoo happens, but basically it gets good at telling you what you want to hear. And that's why they're much more useful than the pure kind of autocomplete version of LLMs.
So I remember, Ben, I think it was Microsoft who had a Twitter girl
right
a few years ago, trained on Facebook stuff.
Yeah.
And it became so racist, they had to shut it down very quickly.
That's right. Yeah.
And so my bias always is that history is not really a good raw material for intelligence. As you probably know, there was an insurance company in New York. I think it was Optum, if I remember correctly. They used previous EMR data and figured that African Americans don't need as much care as white Americans. And that was based on historical observations of how much care was delivered to African Americans. So history is a pretty complicated thing, isn't it?
Oh yeah, there's a lot of problems when you're using the internet as the guide to train. I mean, basically what it's doing is reading the internet, which text on the internet has a lot of problems, and you're introducing potential biases of all sorts of different types when that's the base text that's used. And you see that there's a lot of effort by these companies to sanitize the initial effects of this, right? To curate the data, to make things less offensive, and when it's just trained on certain parts of the internet.
Is that what they call fine tuning, or
that's usually going to happen during the fine tuning phase?
Okay.
I mean, there's a lot that goes on, right? But that's basically it. Is it comes out and it just says stuff from the. I mean, it's not just offensive stuff. It'll also do just all sorts of not useful or helpful things.
Yeah.
And
But
so then there's a lot of effort to clean it up in various ways. And sometimes even, there are techniques other than just the standard, there's all sorts of stuff you can do. It still is far from perfect. If you play around with ChatGPT or Claude or anything long enough, you'll see that it has a lot of flaws remaining.
yeah, it appears to me, Ben, I don't know much about this, but it appears to me philosophy is the right tool to ask this question. So Elisa from MIT in the 1960s was the first chatbot, and it had some interesting things to say as well. And now, 65 years later, we have something much more sophisticated, and it's saying more interesting things. And I always wondered, is this computing power that got us here or something different?
Well, I think it's two factors. So, I mean, one thing you're right on, it's definitely computing power that is behind a lot of the advances. So that with the rise of powerful GPUs, we can just do a lot more stuff with AI that wasn't really workable, earlier, even if we had some of the theory.
Yeah.
But then the other side is just the algorithmic advances. When you talk about ELIZA, that was a very, very simple kind of old-fashioned algorithm.
Yeah.
Where it wasn't really training and learning from the world in anything like the way that ChatGPT does with the sort of transformer model as the architecture. And so that, I think, is, even if you tried to do ELIZA, you'd have to do so much hand coding and everything else. It wouldn't really get you very far. You wouldn't have enough. But even with, a lot of compute, it wouldn't really end up working out practically. Whereas with these architectural advances, where you can kind of I'll say this, right? So it used to be that people would say things about AI like, well, it'll do exactly what you tell it to do, and that's the problem because, right, you code it up and it does it, right. But that's not really what's happening anymore, right? It's not that you're coding it. Like, nature gets to code it too, because you sort of specify an architecture, and then the actual program that it ends up with, the actual computer program that's found, is just based on whatever it observes, from the data set in the wild that you have much less control over. And so the fact that it can kind of make adjustments based on that in a very nimble way is what differentiates it from something like ELIZA, more than just the fact that we have way, way more compute as well.
Yeah, so as I was reading through your paper, I was thinking, so suppose I have a system with an unlimited number of rules. Will that system look anything similar to what we have?
So maybe you could say a little more what you mean by an unlimited number of rules.
An unlimited number of rules, meaning I'm going to represent the world in set of rules, and I have no constraint in terms of hardware or memory or anything. So it can be an unlimited set of rules. And my processing power is so great, I can do a comprehensive search of the whole design space before I make a response. Will that look different from what we currently have?
I think in some level, in principle, no. I mean, at least if you're talking about sort of the fixed model, where after it's trained, right? So you train it, and then it's learned everything it's going to learn, and then you send it off to the user. In principle, there's a way you could hand code that, right? Like, you could just sit down and write a really long Python script yourself, where you just had a bunch of rules with a classical computer program that did everything that it does. In a way, you can just see what the program is very easily. It's very long, but it's just multiplying a bunch of things together with matrices, and then occasionally doing a few nonlinear things along the way. You can follow the arithmetic. It's pretty simple math. Just there's a lot of it. So you could write a high level program that did that. there's not like a theoretical thing that I can think of that would stop you. It's just that it's just a computer program like any other. It's just be very hard to figure out how to do it. Like if you asked me how to write a chatbot that was as good as ChatGPT, but didn't have access to training, it just had to kind of come in, delivered and fully formed.
Right.
That would be very hard to figure out how to do.
So is NLM then really a way to, well, I don't want to call it efficiently, but because, the energy requirements for ChatGPT 4.5 is actually daunting.
Right.
So I don't know if it's efficient, but it's a different way to get to codification of how the world works, right? Is that the way to think about it?
Yeah, it's that we're not just kind of coming up on our own with a bunch of really clever rules and then tweaking as we think of clever things, right? It's like we're letting it learn. I mean, that's the whole thing, is that with the modern algorithms, with gradient descent and backpropagation, we kind of let the program be found based on how it interacts, what it sees in the world.
Yeah. So I was looking up, Ben, that when was gradient descent discovered? The first instance of that is in 1847.
Yeah.
So I'm, as I can imagine, I'm a little bit on the skeptic side here, Ben. So I continue to argue that we don't really have big mathematical advancements, but we have great computing, engineering advancements. And I don't know if it's a philosophical question or not, but sort of the question is, can silicon and energy thrown at a problem at ever expanding rates, could that lead to what is now called artificial intelligence, which I think is a total misnomer. I think what we have is automation, not artificial intelligence. But I mean, if you keep throwing silicon and energy at the problem, do you think we'll get there?
What do you mean? What do you mean by there?
Get there meaning, can we create something that is human-like? So when I think about AI, I'm thinking about, it has consciousness, it has, all the stuff that humans think they have. I actually don't know if humans have them, but isn't that what we are trying to drive toward, that make a human-like robot?
Well, I don't know if we want something human-like, and I don't know if we'll have a good way of making something, human-like in all ways. I mean, consciousness is its own question. I think different from whether we would want to count ChatGPT or some other AI as having a mind, at least in many of the ways that Simon and I were interested in it for this paper.
Yeah.
There's a question of sort of whether AI could be smarter than us or as smart as we are, and all reasonable, like all reasonable aspects of intelligence, right? And that could be something that's very not human-like. It might not have a personality, or might be all sorts of ways that you could be smart without being human. I mean, you could have alien species, right, that are very smart, but that are very smart, but that don't have that aren't human-like in many ways. So I mean, I think, right, do I think that at some level we're all just computer programs? Yeah, all right. I mean, I think that we're kind of computer programs now. Whether modern AI will result in something human-like, I think, is a really big question for safety and all that as well. I think, of course, we can get things that are smarter than human in principle. There's not a natural reason to think that we're kind of at the top of the chain for intelligence, and we know, at least in many narrow domains, we're not at the top of the chain. Right? I mean, there are many things, like not overall, but many certain cognitive tasks that computers have beaten us at since the 40s, right? That's like they've been superhuman at adding two numbers together for a long time. They've been superhuman
Yeah.
at remembering lots of facts, right? They can remember things, but yeah, I think eventually they could beat us in everything cognitive.
Yeah.
There's a question of whether we need more algorithmic advances before that happens, right? Like if you just you take a transformer and you train it on a bunch of data, and it comes up with a pretty good language model, right? You can chat with it.
Yeah.
All right. Then you make a bigger transformer, so it's the same thing with just like
Yes.
more.
Or
And
a
then you
series of
train it on more
transformers
data.
in parallel. Yeah.
Yeah, and it gets better.
Yeah.
And then you do it with even more, and it gets even better. Is that going to take us to something superhuman? I don't know. I feel like it's hard to predict. I would say probably not quite. But I also wouldn't be shocked if it's not that far away from where that is. If you had a few more orders of magnitude of compute, you had a little bit more. You had a few algorithmic improvements. And some stuff that some super smart people, at OpenAI come up with. That wouldn't surprise me if that beat everybody cognitively.
Yeah, I mean, the alternative hypothesis, Ben, I'm just posing this for you to react to. So we had 100 billion people since Homo sapiens arrived on Earth. And one could argue they're all automatons. They were using historical data to survive and do things. And once in a while, we had a real human, might be Isaac Newton, Albert Einstein, or Maxwell. But that bucket is actually quite small in the sense that, they were using some amount of historical data, but they came up with something that is completely unknown at that point. So going back to the LLM and ChatGPT, do you think they will be capable of coming up with things that are not known to regular humans?
So I think that's that's a very hard question to know the answer to, right? I mean, people give you confident answers one way or the other, and I don't think that it hasn't done anything that amazing yet, right?
Yes.
Now, when you say that amazing yet, right? I mean, the bar for what we're amazed by AI has moved quite a bit in the last 18 months, right? Like if I'm coding something now and I want to know, can you, how do I write this short script, right? I mean, the first thing I'm going to do is just ask Claude to do it for me, and that'll usually be pretty good. I'm not a software engineer, but it also helps software engineers with their actual professional work. So it's not like it's coming up. If I say now I need you to invent a totally new algorithm, right? It's not going to be able to do that. But almost no one can do that.
Yes.
Right?
Most people cannot. Yeah.
Yeah. So I think I could see a way of it happening. And it kind of goes a bit to the stuff Simon and I talked about, and other people, of course, have talked about as well with things like world models. So the idea is one view of LLMs that I think is empirically just wrong now is that they're doing kind of shallow pattern matching, right? They have this huge amount of compute. They notice patterns in language. They don't really understand at all what's happening.
Yeah.
But they can kind of pattern match things and well enough that they can make good predictions about what to say without actually having any deeper understanding. So maybe if I said something like, I said, "Hi, Gill, how are?" It can be like, "Oh, this is a common greeting. I'm going to say you next," right? It doesn't really have to know anything. It can just notice that that's a common thing in language. And maybe when you give it certain tests, like the SAT, right? It's read a lot of standardized tests before, and so it does really well in the SAT. But when you try to take something like the SAT or an AP exam or something like that, or the bar exam, if you've seen a lot of this sort of thing before, you might not really understand the answer, right? But it's just I've seen so many of these, I kind of know the way the test takers write things, and I can get the answer without really understanding it, right? That's like one hypothesis.
Yeah.
But I think, at some level, if you're going to get good enough, you have to get at producing text or responding well. You have to get good at understanding like what's really going on. So if I give you like a tricky physics exam, one really good way of figuring out what the, if I say question is the prompt, right? And then I give you like a hard physics problem or a hard engineering problem. And I say, answer, what's the answer? Maybe you can kind of like fake your way into saying like the answer because you've read so many of these before that you can kind of like, string some stuff together. But if you're going to get really good, and the questions like vary a lot and all that, and there's you just have to have like an internal understanding of how physics works. So that's just like, so you have to kind of press the world down into like a model of what's going on, and that's actually going to be the best way of predicting the text. And so if you think it can actually get really good models of what's going on, and the models come about just purely as a means of predicting text originally, right? Like it's just trying to predict text. And to do that, it makes this big internal world model and this internal representation of how reality is.
Right.
Then, if it has good enough models, it might be that you ask it a question that no human has the answer to, but it it follows from its model. It knows what to say. Because it's like figured out a good representation of reality. So that's, that's speculation at this point, because it's not like we have LLMs that are at, right now doing a lot to advance science or mathematics or philosophy. But it's not like I see that there's some kind of, you can see a story of how that might come about.
Yeah, so I know that you have some timing constraints. You have to come back. So I'm going to go a little bit on a tangent here. So, SAT and the bar exams that you mentioned, the questions are created by humans. And humans have limited capacity, as we all know. And so in a grander scheme here, do you think machines will be dominant in that sense? In a regime where humans are creating stuff based on their experiences and their knowledge and information, I think machines will be able to dominate that, right? Because their internal memory and processing capabilities could potentially get to a level that is a lot higher than a typical human.
Yeah, I think eventually, right? So that once you hit a certain level of cognitive capacity, right? It's just that certain humans are able to dominate that over other humans.
Yes.
Right. And you see that even at the fairly high levels, right? Their abilities in mathematics come in very, very, very long levels of distinction, right? Even between someone who's a really good undergraduate to a really good graduate student to a strong professor, to say Terry Tao, there's a big grade, big jump between all those. And and then AI, I could imagine eventually, not just because of compute, but just like because it's understands things better too, right? That's in a way where we've had advantages before, is that right? We were dominated in many sort of raw horsepower things, where it's just kind of brute force with compute.
And they don't suffer from ADHD, so this is sort of an advantage for machines. Humans get distracted, as you know, very, very quickly.
Right.
So if you have algorithms that are sort of very focused on getting to the problem solution, it's likely to be dominant over time, right?
Yeah, I would think eventually we would be able to automate science and technological discovery with that, right? Like humans would just be out-competed. And so we're hoping that their interests would be aligned with ours well enough that if they do that, it would be, it would go well for humanity.
So I want to go back into the paper. So we have a number of things here. So we won't be able to get through them. And so you have to come back at some point. So You say here the first key question is whether LLMs have robust internal representations of the world.
Right.
Here, our strategy will be to survey various philosophical theories of representation and see whether LLMs satisfy the theories.
Mm-hmm.
So, do they really have robust internal representation of the world?
I think so. Yeah. So maybe I can just situate this a little bit. So the idea was thinking first whether they have minds in a certain sense that we operationalize. We say, do they have things like that are kind of like beliefs about how the world is and desires, the ways they want the world to be. And I can get into like why we think that's one of the most key questions for thinking about these. And then kind of for the question of whether they have beliefs, one really important question is whether they represent the world as you just laid out. And what we're kind of saying was that whether they have minds in the fuller sense is still very open, but whether they have mental representations, we think the data, the empirical data really, along with the philosophical theories of representation, they kind of all point to yes, right? Now it's not maybe a complete slam dunk, but that if you look at what it means to have a representation, how people have thought about that, and what we know empirically about LLMs, we should really kind of think of them as having, internal representations.
So let me ask you this, Ben. So I haven't really thought through this. So I was an engineer. I was doing what was then called finite element models, FEM, and computation fluid dynamics models. So we could actually create a model of an aircraft in mathematics.
Mm-hmm.
And then that model could tell us things that it hasn't been trained on, quote unquote. What happens when when there's a thunderstorm, or what happens when some sort of particle hits the wing or whatever, right? That model could tell us all those things. But it's a mathematical model. It's not really trained, quote unquote, on anything. So we have proxies for what you're observing in some ways. I mean, maybe I'm not thinking about this properly. So what are your thoughts on mathematical models of systems that could tell us a lot of things that they haven't been trained on?
Yeah, that's a great question, and I think kind of what you're getting at, that is really, it has something I would say is the mathematical model you have has one of the key aspects, or at least one of the key aspects of representation. But I wouldn't call it maybe a whole mental representation, because it's also missing, some other key components, and it's not really playing the right role in a broader system. So I think kind of, so one of the things that it has the sort of structure, what we call structural isomorphism between the model and features of reality, right? So that kind of whenever there's something important about the airplane, at least important for ways that you would care about, there'd be some sort of part of the model that accounts for that. And so that if I manipulate some parts of the model, that would correspond to some manipulation of the airplane, and so on. So that's, I think, one thing that's really important for representations. Another thing that it has counting as a representation is that it can allow you to ask, it sort of abstracts away from certain features as well. So I guess maybe this is a terrible thing for me to speculate about, because I actually have no idea what matters for airplanes, right? But like some things don't matter about an airplane that you don't really need them in your model. So like things like, the shape of the wing, I would assume matters. I'm going to just guess. I'm not an engineer. I imagine wing shape really matters. But like whether one logo, like a Southwest logo is painted on the tail, or a United logo is painted on the tail, probably won't matter for the thing you care about, and that's not going to be represented in the model, right? So like not every single aspect matter. It's just the sort of, we've kind of compressed it down and abstracted away, and so in that sense, it's a very good representation. Now, that isn't embedded in a lot, a larger system, and so there's a lot more we could say about maybe why it's a lot different from, say, how ChatGPT could represent the world in other ways that it would have representations. But yeah, I mean, I think they are a kind of representation, are these mathematical models, and that's one of the reasons that they count as good. Now, the interesting thing I think about ChatGPT is, right, it's sort of internally building these models of reality on the fly as it's trained about the world. It's making them up itself. It's kind of figuring out how they go and reasoning about them and using them to generate text, and also in a much broader domain, right? It's not constrained to this one narrow thing of like an airplane. You can ask it to write, rap lyrics. You can ask it to code in C. You can ask it to play chess and all these different things, right? It's able to interact with you based on its internal representations, which is something an airplane model wouldn't be able to do.
Yeah, so it's a sort of a generalization question. So you say here, internal representations alone are not sufficient for a full-blown folk psychology.
Yeah.
So what do you mean by folk psychology?
Good. So when we say folk psychology is like, no, it sounds almost, I'll say,
folksy.
Folksy, yeah, it sounds folksy, but I would say it sounds almost disparaging, right? Like it sounds like a term of abuse. But it's actually, I think, one of the best theories. It's a great theory. So yeah, and we use it all the time. So what we mean by folk psychology is really like belief desire psychology. So belief, desires, intentions, or something. So if someone does something, let's say, I don't know. We always use the most boring examples in philosophy. So I say, like, someone goes to the refrigerator, right? And you say, like, well, why did that happen? You say, well, the person desired chocolate and believed chocolate was like in the refrigerator, so she went to the refrigerator to get chocolate. Something like that. Very mundane explanation, but I can like very well explain why the person did something based on beliefs and desires, right? Like if I say, like, why did someone invest in one stock or one ETF instead of another? It's like, well, wanted money and believed that would get more of it, like maybe with a lower risk or something, right? Like these are the sorts of explanations you give. So I explain actions based on beliefs and desires all the time. You can go home and think about when you ask, like, you talk about other people a lot, or maybe yourself, and rationalize like what's going on or like why people do things, and it's very much in terms of beliefs and desires. And so maybe we'll say this, right? So it's like how we understand other people and ourselves is largely on these terms, and it's more than a pure folk theory, right? Like if you think about microeconomics and decision theory and game theory and all this prospect theory and psychology, these are all really just like fancy ways of doing belief, desire, folk psychology. So the thought was, look, if we want to think about ChatGPT, right? If we think these LLMs are going to play a bigger and bigger role in society, and they're kind of like humans. Like we talk to them, we ask them to do tasks, we might ask them to like interview job candidates. Well, we're going to use them to automate a lot of these sorts of tasks. We want to understand what they have in mind. Well, using the best theory that we have for reasoning about other people, it'd be nice to know whether and to what extent we can use that kind of framework for thinking about ChatGPT. So that was the kind of the key question, was when we think about that, we think this is how we really reason about humans and beliefs and desires, intentions, and when we want to predict their behavior, that's how we often do it. With how we do it, not just in day-to-day life, but in more serious contexts as well. I'd say more serious and more formal or whatever contexts as well, like formal theories of choice. Is there anything to that? Can we kind of use those resources that are very good and work very well and are very successful when talking about LLMs?
Yeah. So So definitely, I know that you have to go pick up your kids, so we have to have another session.
Mm-hmm.
But there's so much in this paper, Ben, that
Oh,
I
thanks.
found very, very interesting. Um, so just to sort of a teaser, you say here, we look at a range of conditions on representation, including that the system has internal states that carry information about the world, that these internal states are casually effective at
Oh,
that
sorry, you cut off for a second. Yeah.
okay, that these internal states are casually effective at producing the system's behavior,
Mm.
that this internal representation satisfies four patterns of reasoning, and the structure of this internal representations mirrors the structure of what they represent, that the information carrying capacity of these representations emerge from some kind of selective evolutionary process. So I find this really, really fascinating, Ben. So in some sense, you're arguing when you do the LLMs, there is an evolutionary process going on there. Just to throw out my bias, Ben, I'm on the stochastic parrot
Mm-hmm.
line, but I find this really interesting. I mean, if we can prove this is actually happening, that's a lot of implications, right, for the future.
Yeah, I mean, there are a lot of disanalogies between, say, gradient descent, where you're making these sort of very minor tweaks to the parameters of the model,
Yeah.
and evolution by natural selection. But one of the claims you make in the paper was, look, it's they're different, but the ways that they're different don't really matter for the point of view of this, the theories of representation. So if we're thinking about representation, the fact that it is selected in this way rather than selected in the more well-known way, or the in biology,
Hmm.
that's not really like an important difference for that purpose, right? It still leads to this representation,
Yeah.
internal representation.
Yeah. So this is sort of a fundamental thing, right? So does LLMs and ChatGPT more generally have an internal representation that is more generalizable, that they could actually use those representations to answer questions they haven't really answered before? And that's sort of a fundamental shift, isn't it? I mean, as we think about these systems.
Yeah, and I think that's the real question. There's also a lot of some of the work we talk about with behavioral stuff of like, can it figure this out? And sometimes the answer is no, but sometimes the answer is yes, that it surprisingly is able to figure out new things it wasn't trained on in very impressive ways, to my mind. Now, there's always still, like, for any particular question, you can always say, was it really just stitching together things like a stochastic parrot, where it's doing some simple pattern matching rather than some like deeper understanding? But I mean, if you think of the fact that we have both the behavioral data and we have some way of decoding these internal representations with this interpretability research, which maybe we can get into at some point. That seems really compelling to me, to think that the best explanation right now is that it has these, sometimes has relatively robust representations that are allowing it to kind of get the right answer in a new domain or in a new type of question.
Excellent, Ben. So I look forward to our next session. We had some technical issues, but hopefully we can have some more time to go through the paper. Yeah.
Great. I'm happy to do that, and maybe we'll figure it out. So
Yeah.
All right. Well,
thank you.
Session 1 was very very enjoyable. Nice talking.
Thanks. Bye.